Welcome to the Downtime from WTWH Media with your hosts, Sarah Wynn and Sherry Kasperzak, bringing you everything you need to know from the week in manufacturing.
Hey, we are #thankful, grateful, blessed to be back with another episode of the Downtime. We are a weekly manufacturing podcast from WTWH Media. WTWH stands for Willing to Work Harder, and that's what we aim to do each and every week. I am Sarah Wynn, senior editor, and one half of the Downtime Divas. Let me tag in my tag team partner.
Hey, it's Sherry Kasperzak, Executive Editor of Automation and Control Brands here at WTWH Media. And if you don't know, that is Plant Engineering, Control Engineering, and Consulting Specifying Engineer, welcoming you back for another episode of The Downtime. We're so glad you're here.
It's a pleasure, Sherry. Pleasure to be back. We have a lot on deck. Today's episode, we dive into the world of robotics and automation, featuring an interview with Fanuc America's senior engineer, Stacey Harimoto. You do not want to miss that. Stay tuned, but let's address the fit. Is there a fit check you want to do before we dive into our headlines?
You know, I'm keeping it simple today. It's cold here, rainy here in Rhode Island. I know you're shocked it's raining in Rhode Island. It always rains in Rhode Island. So tell me about your OSU hat. Let's hear it.
Oh, this is a repeat hat. This is not a new hat for the show, but it's a big month. Go Buckeyes, #1 team in the country, knock on wood. We have a really big month ahead. I'm not going to jinx us, but I'll just say, Sherry, OH.
IO, yeah.
Yeah, there you go. This is a nice little Ohio State hat I bought at the airport, and Sherry gave me her input on it. So yes, thank you for asking, Sherry. Thank you for asking.
Absolutely. We always have to talk about the hat, always.
Okay, we will segue into headlines, and I have a lot going on at packagingoem.com. We have a brand new ebook. That's right, Sherry. Sherry's been chomping at the bit, waiting for this ebook to come out. And guess what? It's here. Yay. We dive into how conveyors have advanced from simple product transport to the backbone of control and communication on the plant floor. This is a free ebook you can download on Packaging OEM's website about material handling and conveyance. We will explain more on the upcoming episodes of the Downtime, but the report is available now, Sherry, now.
Go get it.
We also have an OEM profile on Morrison Container Handling Solutions. A lot of different voices intertwined in this piece. That's up on Packaging OEM's website. And one more for you. We have a news story on Serpa's new drop packer. It made its debut at Pack Expo Las Vegas. The story features video from the show captured by our boss, our supervisor, aka the GOAT, the head of the table, Stephanie Neal. So check that out. All up on Packaging OEM's website and social media right now.
Go check it out, packagingoem.com. We love it. Thank you so much, Sarah. So over at plantengineering.com, we've got a really cool expert panel. Now, I don't know about you, but I love getting that sort of expert advice. Every month we have a new panel that comes out on a particular topic. This time it's on variable frequency drives, variable safety drives, VFDs and VSDs. We have a panel that consists of Andrew Fishbach, he's with Hitachi Global Air Power, and Benjamin Strong, he is with Mitsubishi Electric Automation. These experts, they have some great insights into how variable frequency drives and variable speed drives offer advantages on the manufacturing floor, the ways in which drive manufacturers are making VFDs and VSDs more plug and play for original equipment manufacturers, and how VFDs can maximize efficiency and minimize energy usage in plants. So head on over to plantengineering.com and check out our awesome expert panel on VFDs and VSDs.
Wow, an all-star panel. You got to check that out. Wow.
You got it.
And now we will move into our interview segment. Sherry, we have an interview with a very special guest. Her name is Stacey Harimoto. She is a senior engineer at Fanuc America. She dives into her inspiring journey from her early days growing up in the Lego League to becoming a key innovator in warehousing and logistics robotics.
Yeah, Stacey was such a pleasure to chat with, and in our interview we explore her path in engineering, her work with robotic tote consolidation, and exciting developments in industrial automation. She was such a delight to talk to.
Yes, and she shares a really inspiring story about how she got her job at Fanuc.
Absolutely. Let's jump right in. Here's Stacey's perspective on how robotics is solving real-world problems. Take it away, Stacey.
All right, welcome back to the Downtime. Sherry and I are here with Stacey Harimoto, Senior Engineer at Fanuc America. Stacey, welcome to the show.
Thank you so much for having me. I'm excited to be here.
Thanks so much, Stacey.
Stacey, we met back at ProMat. I like to say Stacey's the star of the packaging OEM RFID token consolidation demo. If you haven't seen it, make sure to go check it out. But Stacey, can you kind of guide us in your path? What first got you into robotics and automation? Was there a moment that you kind of had like a light bulb go off in your head, like this is for me?
So I actually started out in First Lego League back in middle school. The high schoolers came in to our gym and said, "Hey, look at these cool things we're doing," drove their robot around. And I thought it was so cool. I was like, you know what? I'm going to try that. And I loved the first 2 years of it. And then I moved on to VEX, which is more of a high school kind of realm. And I had these really cool moments of like getting to build, design, program the robots, drive them around, meet other people that I absolutely loved. I definitely had this one moment though of like, I am a female in engineering and I can do this and I can prove myself throughout the years. There was this one competition we went to. I remember it was a really snowy day and we were competing. We were trying to qualify for the world's competition. And as part of this competition, it's not only like how do you work as a team, how does your robot perform? You also have to speak to judges. And what I didn't realize at the time is that it's teaching you how to talk about what you're doing and communicate. But there were 2 college kids that came over to our table that were judges. So they were helping volunteer, which I really appreciated. But I remember them coming over and it was 2 guys and I was on an all-girls team. And the stereotype is, the girls are just there because their parents want them to be there. And they're there just to drive the robot around and have fun. So these guys came up and, they're asking the most basic questions of, tell us about your robot. And you could kind of see in their eyes that they didn't care. They weren't expecting anything. And this just light bulb went off. And I was like, no, we did all this work. I'm going to prove it to them. And I took out the notebook and I flipped it open. I said, oh, well, we designed our robot this way. We have 6 wheels so that, and the middle 2 sets are raised up so that whenever we go over this bump, there's always 4 wheels on the ground, and kind of explaining that. And as I go into it, I'm like, oh, and Lexi, can you explain this? Megna, can you explain this? And you can see their eyes kind of widen and the realization of we're like becoming real engineers here. We can do this. And just that moment of I can do it and prove myself and prove our team was really formative for me, and powerful. And I clearly still hold on to it this day. But it was one of those things of, yeah, I'm a woman in engineering. I can do it. I can prove it. It's, yeah,
That's
it was
awesome.
a great moment.
So what would you say, what would your advice be to a woman who is considering, a young woman who is like considering engineering as a career, but maybe they're not sure, maybe they have that moment of, oh, no one's going to take me seriously. Like, what would your advice be?
I would say you can do it, prove it to yourself, and you can prove it to others. I found a really good group of girls to work with. I was on an all-girls team, but I was on a team of girls that were passionate about it as well. We all still actually hang out. We're all doing something in the engineering space of some sort. Some are in automotive, some are in robotics, some are playing with lasers. So, we're still all over the place, but we learn to work together and support each other. And that was huge. And just knowing that, like, if you find someone that's not respecting you, you don't have to associate with them. There are other people out there. Just find your people, find your space.
Absolutely.
Great advice. And so, Stacey, let's talk about Fanuc. What brought you to Fanuc and what excites you the most about the work you do now?
So at my first internship, which was at L&L Products, I got to see robots in action. They were manufacturing, and one of the projects I did was helping watch a robot unload a machine and analyze it, look at the code, see how I can speed it up. And getting to watch it speed up and my changes make an impact was huge for me. And one of the robots that they had was a Fanuc robot. So I went to college outside of the state of Michigan, which is where my internships were, where I grew up, where Fanuc headquarters are. And so Fanuc doesn't come down to Missouri to recruit. They stay in their Michigan area, which I totally understand. So what I actually did was I cold called Fanuc to see if they had any internship opportunities. It was one of those things that I thought was really cool, really exciting, and it was just worth the call. And it ended up working out really well. I interned there for 3 summers while I finished my bachelor's and master's degrees. And now I've been here for over 5 years full time. But I love the variety of work and the impact that I feel I have on the industry.
That's awesome. Stacey, could you share where you went to undergrad and you got your
So
master's?
yes, I got my bachelor's in systems engineering and my master's in mechanical engineering at Washington University in St. Louis. And then while I was working full time at Fanuc, I worked on my MBA part-time through Penn State.
Awesome. Big Ten, Big Ten. And I do love the cold call story. You know, if you never ask, you'll never know. I do love that.
For sure. Was there anything you kind of initially wanted to go into in terms of engineering that you kind of like, took a hard right and went in another direction? Like, was there anything you studied that you thought might be your career instead of robotics?
So I actually, when I was in high school, right, and you're applying to colleges, you don't know what a real engineering role looks like.
Right.
You think, oh, I want to do mechanical or systems or electrical or computer science, but you don't know what that really looks like in the real world. One of the internships that I had actually at L&L Products, I had this incredible opportunity. And it was summer after freshman year of college. And, I was talking to my mentor and I was saying, hey, I really don't know what these different roles mean, right? I'm working as an applications intern here and kind of overseeing the broad idea of, or the broad spectrum of jobs at this company, but what does it really mean? And they said, you know what? We're going to help you out. Let's let you shadow the different engineering departments. So I spent a couple of weeks where I shadowed the mechanical engineers, the computer science engineers, the robotics engineers, the product or the application engineers, the product developers, just to really understand what they did. And so between that and then taking the different intro courses at school, and I went into the intro to electrical engineering class, and 2 days into it, I said, you know what? Electricity is a little scary. I don't need to do this. I decided computer science, I didn't want to sit at my computer all day. I wanted to see physical changes, especially after seeing that robot move faster. So that's kind of what drove me to robotics. I think robotics was at the core of, my excitement of engineering, but it really gave me the opportunity to see what the different paths are and how I could apply that.
For sure, Stacey. Thank you. And along the way, have there been any mentors or former supervisors, or even colleagues that have stood out and kind of helped shape your journey and how you approach engineering?
So many. I absolutely would not be where I am today without the support of people around me. And that's why I actually love mentoring students and interns today. The summer is so fun getting to watch the interns grow and learn. And it's a very exciting time for me. But a couple of them were Steve Balsam, who was my mentor at L&L Products, that gave me that opportunity to see what the different engineering jobs looked like. Another thing I did was I went to a Society of Women Engineers event called Dinner and Dessert with the Firms. And it's one of those events where you're not allowed to bring resumes. It was really meant for you to just chat with people in the industry. And at one of my tables, I sat down with Ryan Odegaard, who at the time was a manager at the GM plant nearby me in Missouri. And I talked to him about my past internships at L&L Products and Fanuc. And I asked him about advice on whether to go straight into the industry after finishing my bachelor's, or if I should get my master's in engineering or pursue an MBA before going into the industry, especially because my school had a 5-year BSMS program. So it was one of those things where it's a good opportunity, but I know it takes the extra year. What does he think? Would it help me or not? And we were really getting into my knowledge and where I was at and where I wanted to go. And I really valued that interaction. And so after the fact, I got his business card and I sent a little thank you email just for his advice. And what I didn't expect was what came next. This next semester, he emailed me out of the blue and just asking if I was going to be at the career fair the next day and I should come say hello. So I thought, yes, absolutely. I will definitely come see you. And when I showed up, he said that they had a part-time position open and he wanted me to interview. And it was one of those opportunities that I hadn't considered before, but it was great. I interviewed, I got the position, I got to play with more Fanuc robots in the manufacturing world. And he was just really great at mentoring me, making sure that he helped me with any goals that I had. And ultimately, I ended up here at Fanuc, but sometimes when he happens to be in the area, he'll let me know and I'll still say hi to him. And then, of course, at Fanuc, I have so many different people that I look up to. I get to see how they lead, how they interact with peers, how they interact with customers, and I'm really learning from watching them. So it all comes together to give me the confidence in the role I have today. So I would love to thank every single person that's helped me out.
You can definitely feel the gratitude. And we're doing this over Zoom, but I can feel it. I appreciate you sharing that, Stacey. Thank you.
For sure.
Do you want to kind of talk, Stacey, what your day-to-day looks like at Fanuc as a senior engineer?
Yeah. So I have a lot of different roles. I have a very interesting kind of perspective on what an engineer does. I wear a lot of hats is how all that it comes down to, but I am the lead on all warehousing and logistics robotic applications. So I am like an application specific person. So I don't concentrate on just industrial robots or collaborative robots or large robots, small robots, whatever it may be. I want to help the customers find the best solution for them. So I work a lot with sales and integrators and customers. I'll do simulations and recommend the best robot for their application and support them through the life of their robots. So especially in the warehousing and logistics industry, there's a lot of unknowns. There's a lot of, what size box is it? What shape bag is it? What's the material? How heavy is it? And that's not your typical manufacturing, right? So in manufacturing, it's typically, I'm making 1,000 of this part and 500 of this part, and they all look exactly the same, barring any manufacturing defects, right? Where this is, everything is different. And so that poses its own challenges, and that's what I'm really enjoying about my role. But because of those different challenges and the differences in this logistics market, I'm working a lot with the product managers and the research and development team to tell them what we need next for our customers to help create the best products for them, whether it be a new product or a feature. I want to help make sure we grow with the market. And then, as you mentioned earlier, Sarah, I create demonstration cells. So I get to come up with the concepts, design them, mechanically build them, program them, and bring them to the trade shows where I get to talk about the solutions to potential customers and connect with the industry and meet you both. So it's a really fun time. I have a big variety of work, whether it be at my computer, in the lab, at the trade show. So that's what I'm really enjoying.
Definitely. I love that you brought up the different products, like different shapes and sizes, because when we met, you had the RFID toe consolidation demo and you had a plush toy that was moving around. So thank you for bringing that back up. And Sherry, did you have a question? I'm sorry if I cut you off.
No, absolutely. So, I think it's really great that you have like sort of this direct line to, clients and customers. Is there sort of, a common like pain point that you're hearing from a lot of customers? What sort of things are they dealing with that they need a solution for? Or, is it a variety of things depending on the customer?
It definitely depends on the customer. I would say in general, a lot of places are looking for help because of labor shortages or costs. It's hard to find people that want to do this kind of job day in, day out. In the warehousing industry, for myself, a lot of it is moving boxes, and those can go up to 50 pounds, and there's all those ergonomic issues. I know that the number of annual submissions are increasing steadily. I did some research and actually spoke at a different trade show about this, but 3 of the top 5 industries of these different ergonomic issues, relate to my work. So manufacturing, retail, and transportation and warehousing. So that's 44% of submissions. And about 90% of the 1.5 million cases were injuries that resulted in days away from work or job transfers and restrictions. So it's those kinds of things that don't make people want to work in manufacturing or this industry. So between that and the demand for efficiency, customers looking for higher volume and more customization, or even trying to grow domestic manufacturing and production and jobs, automation and robotics can help that happen. But from the engineering side, one of the big things that the customers are looking for is being able to identify different products in a bin and picking up that specific item, which is part of what I was doing with my tote consolidation cell. However, the vision isn't quite there yet. AI helps, but even if you do try to identify the item, it's hard to pick all those specific items with one gripper. Being able to pick up, a phone case that's very square and hard versus a plush toy. Maybe it's a dog toy with a squeaker in it, whatever it may be. Maybe it's string, maybe it's, a bagged clothing item. All of those you pick up different ways, and it's not something you think about with your own hands. It's very easy for us to figure out how to grasp something in different ways, but when you have a mechanical gripper or a pneumatic gripper, you can't grab it the same way every time. So that's been the challenge that I've seen my customers have, and something that's still being developed.
Definitely. Thank you, Stacey. Oh, go for it, Sherry.
No, I was just going to say thank you. Yeah, I'm seeing a lot about, just sort of tactile, innovations in robotics and, basically training them how to grip things and not apply quite so much pressure. You don't want to crush some delicate things. So yeah, I can understand that.
Yeah, we're big fans of the plush toys, the little dog toys over here. So I appreciate that. And then in terms of Stacey, so I write a lot for OEMs for packaging, and in terms of warehouse, what do you think about the next few years in robotics and those industries? Any exciting things that you see are possibly on the radar or on the horizon?
So I think for me, a lot of it comes back to AI-driven vision systems in order to help with that bin picking and quality inspection. So being able to identify specific items, like if we have a bin of 10 different items, it's very easy for us as humans to find the water bottle. But is that water bottle in a box or is it in a bag? Can you see it all or not? Is it buried under something? It's very easy for us to find it, but machine vision, not as much yet. So that's something that I think a lot of people are working on. And I'm excited to see the developments in the next few years.
Definitely. And the big picture, so you mentioned you work on these cells for different trade shows. Can you give us any info on maybe one you're working on now, or when we can expect to see your next robotic cell?
So the next time I'll be at a trade show is at Modex in 2026. I'm actually going to be bringing my same demonstration, the tote consolidation cell, which I'm very excited about. I really like it because it shows a lot in one very small space, which it solves a lot of major logistics problems. So I'm very excited about that one.
Definitely. Do you want to highlight the controller that was used in that? I know that was a big piece of it.
Yes, yeah. So I guess first I'll start with the overall cell. So the purpose of tote consolidation is to bring all the products to the closest part of the warehouse. So fulfillment centers can range from 50,000 to 1,000,000 square feet. And anytime a product is ordered, someone has to get the item from a bin. And if that person or the bin has to travel from the back of the warehouse, it's extra time and cost. So if we can take all of those half full bins and combine them and leave the empty ones in the back, the orderable items are a lot closer to the picking station. So that saves you a lot of time and money. And when we're consolidating, we're not just dumping the whole bin at once. As you mentioned, Sarah, we're RFID scanning each individual item. And that's to confirm the product type and count. So there could be a mismatch from the supplier. Perhaps they put 29 or 31 instead of 30 products in the box. Or if an item falls out of the bin during the transfers or maybe in the back of the warehouse, we want to be able to be aware of that because we don't want to sell 3 water bottles when we only have 2. And as you mentioned, Sarah, we have this new controller. It's the R50IA controller. And the reason I wanted to talk about everything that the robot's doing first is because the controller is not only controlling the robot, but it's also doing the communications for the RFID scanning. There are multiple cameras on the system that are set up. We have 2 2D cameras that are barcode reading. We have 1 3D camera to find products in a bin to pick. We have another 2D camera doing a level check to make sure I don't crush any bin or any products in the bins as I'm circulating them. And I'm also controlling all the IO to do that recirculation and transfer the bins and dump the old stuff into the other side just to make sure I can keep this demo going all day. And just one controller is doing that all. I'm even communicating to my server to let it know the count of each product so that I can update my screens and my database to kind of let the system know what's happening. So all of that in just one controller.
Awesome. And that we do have a story on Packaging OEM about Stacey's demo and the other demos that were operated with this controller, including high payload depalletizing, a medium-sized depalletizing. So I do appreciate that, Stacey. Thank you. And Sherry, do you have any questions before I open it up to Stacey and we talk about her life outside of engineering?
No, I'm just so grateful that you joined us on the Downtime. We really appreciate it.
Yeah, thank you so much for having me. This is really fun.
Yes, Stacey. Okay, now this is the fun part. When you're not working on robots, what do you like to do?
Oh, I do a lot of different things. It could be crafting and hang out with friends. I like to have some sort of creative output. I love traveling to see different parts of the world, especially nature and the different cultures that are out there. And then one other thing that I love to do is rock climbing. So in Michigan, there's not a lot of mountains to climb, if you will. So typically I'm in the gym, but at least once a year, I try to go to Red River Gorge, which is this beautiful place in Kentucky. And I'll go rock climbing outdoors there. So I have fun in nature as well as with the robots.
Yes, I was going to say not a lot to climb in Michigan. No, but
No.
well, that sounds like you have quite a busy life, Stacey, and I appreciate you taking just a few moments to talk with us about it, about your advice for engineers, women entering the field, considering it, along with your work at Fanuc. I appreciate it.
Thank you so much for having me.
Thanks so much, Stacey.
All right, Stacey, thank you so much for joining us. Thank you to the team at Fanuc America. You can also check out that story on Packaging OEM's website, Stacey's Tote Consolidation Cell. We have a video demonstration as well. Make sure to check that out. So Sherry, I think it's time to segue into the game.
Let's play. Let's do it. Woohoo!
All right. So this is a nice, quick, little easy game. It's called Robot Rapid Fire. Sherry and I will quickly decide whether we would feel comfortable giving a robot a simple task.
All right. We love it. We'll each take turns and hopefully it will be fast, fun, and maybe a little bit controversial. Maybe. We'll see.
All right. There are 6 rounds here. So I will start round 1. Ding, ding, ding. In terms of robots, Sherry, would you hand them over your keys to drive a car in city traffic?
Absolutely not. I live in Providence, Rhode Island, and the drivers here are absolutely terrible. I barely trust myself to drive in these conditions. So, no.
I would say no, and I'll tie this regionally too. If you are driving in Columbus, Ohio, I would not advise a robot to drive because the city there is awful drivers. It's not just me saying it. Everybody says it. There's data too. So no, I wouldn't do that. Next one. What do you think?
There you go. So round 2, Sarah, would you let a robot make your morning latte and do the latte art too?
Yes, I would. But make sure to use coconut milk. I'm lactose intolerant. Robots seem to have precision, so make sure this espresso is just right. And in terms of latte art, I would like a little Shih Tzu on the top. Very cute. What about you?
You can do that for sure. Yeah, anything that makes my caffeine intake faster and more convenient, I am there for it. Yes, absolutely.
All right, this one is a special one I threw in for Stacey, paying a little homage to her. Would you trust your robot to scan your RFID tags?
You bet. Of course I would. That's so fun.
I say absolutely, especially if Stacey Harimoto is programming that robotic cell. 100%, 100%.
Absolutely. All right. So, Sarah, would you trust a robot to perform surgery on you?
It probably would have a steadier hand than I would, but probably not. At least not right now. What about you?
Okay. I mean, I would trust robotic surgery. I think given the innovations in robotic surgery, yeah, I think I'd trust a robot to do surgery.
Next one, I like this one. How would you feel about a robot babysitting your children or your pets?
Oh no, Sarah, like, and it's not about the kids or the pets. It's for the robot's safety. Like, there's no way. That robot wouldn't last like an hour here. Absolutely not.
Oh, not even an hour. Okay. I don't have human children. I do have 3 little dogs, and they're high maintenance. I'm not going to put the robot through that. So, no, I'll take care of them. I'll take care of them. And then we got one more, Sherry. What is it?
All right. So, Sarah, would you trust a robot to play a musical instrument in a band?
I do think Sarah and the Cobots has a cool name.
That's a
Yeah.
very cool band name. I love that.
Yeah, like Sarah and the Cobots. Ooh, yeah. So sure, why not? Why not? Yeah.
Yeah, I mean, why not? I think that, I mean, a robot could probably be trained very well to play an instrument. I think that that's probably something a robot could do very flawlessly. So,
Yeah, like Sherry and the robotic violin. Yeah, like it just sounds cool. It just
why
sounds
not?
cool.
Let's do it.
So that is it. That's the robot rapid fire game. Thank you. Thank you. We will wrap this episode up now. Thank you again to Fanuc America. Thank you again to Stacey Harimoto. Thank you again to my wonderful co-host, Sherry Kasper-Zach. Where can they find us?
They can find us over on LinkedIn at The Downtime. You can also find us at Instagram at the.downtime. And you can check out the podcast at SoundCloud, Spotify, and YouTube, and at plantengineering.com and packagingoem.com. Did I catch it all there, Sarah?
Yes, I just lobbed it up for you and you slammed it on down. I love it. I love it.
That's how we do. Awesome. Yeah, this was such a great episode. And thank you so much, Sarah, for being so awesome. Thanks again to Stacey at Fanuc. We had a great conversation with you. And I think that brings us to the end of another episode of The Downtime. It always comes too soon.
Yes, and I will end it the way I started it. We are #thankful, grateful, blessed. The Downtime is a weekly manufacturing podcast from WTWH Media. Check us out, plantengineering.com, packagingoem.com. We'll see you later.
Thanks so much, and we'll catch you in the next one. Bye.